Hello everyone, it's actually 2 p.m. Eastern, and that means it's time to begin another of our monthly CoCoRaHS Weather Talk webinars. And our CoCoRaHS Weather Talk webinar will be going on vacation starting next month, but we'll be back again with you sometime later this summer. So thanks for joining us today. I'm your host, Henry Regis. Running the technical side of our program are both Noah Newman and Zach Schwalbe here at the CoCoRaHS studios. We're coming to you live from the Colorado Climate Center here at Colorado State University in what is a snowy day in Fort Collins, Colorado. For those of you who are unable to join us for our live broadcast, we'll be recording this for future viewings on our website. All of our Weather Talk webinars are sponsored by grants from NOAA's Office of Education and the National Science Foundation. Well, during today's webinar, we're going to be exploring agricultural meteorology, both in the United States and internationally. And we're excited to have with us today two good friends of CoCoRaHS, Brad Rippey and Mark Brusberg. They're both meteorologists working for the USDA's Office of the Chief Economist in Washington, D.C. Well, welcome, gentlemen. Thank you for taking the time to be with us today. I heard it was a snowy commute on your way in, and we're glad you made it there okay.
Thanks, Henry. Appreciate it. Thank you all for joining us today. We did have a couple inches of snow here this morning in Washington, but we are in a warm office, and I hope everybody out there listening in today is in a warm house or office, being able to take advantage of this late winter weather we're having all across the country to sit in on this agricultural meteorology webinar, number 39. We are going to talk both about the U.S., first of all, and I'm Brad Rippey. I will be talking mostly about the U.S. side of things, some of our U.S. activities. Then after I finish up, Mark Brusberg, my supervisor, will be coming in and talking about our role in USDA, or where we stand in USDA, and also some of the international activities that we have. And there's a little bit of a pun on the title there, the layer upon layer, a bit of a double meaning there, because I want to talk about two things. We have obviously the atmosphere above us and the soil below us, both of those absolutely critical to agriculture.
And sorry to interrupt here, but if you can actually, now we've got your screen showing. Okay, we couldn't see your screen yet, but I think we can now. We're looking good. Thanks.
All right, sorry about that. And so the other part of it is, besides the atmosphere and the soil, we also want to talk about layer upon layer, meaning how we layer weather and crop data to come up with an assessment of how weather is impacting agriculture. So first of all, with I'm having a little trouble with the keyboard response here. Try the mouse. There we go. Of course, most of us spend the majority of our lives in the lower atmosphere. That is the part of our world that we sample the best with measurements. Of course, we get accurate temperature and precipitation measurements in all of our land surfaces, at least those that are populated. But even there, even in the part that we inhabit, we have to supplement that with some sensors, satellites, especially over the oceans and sparsely populated areas. Now, as you move down into the soil layer, that's where things get a little dicey in terms of monitoring. We do a very good job measuring everything from the surface to the ground up. But once you get to the Earth's surface and below, that's where our sensors become very sparse. We have very few soil moisture and soil temperature sensors. If you consider surface water to be a part of that, we do a decent job with river gauges, reservoir levels, for example. But once we get into the topsoil and the root zone layer, we have to supplement that with a lot of computer power. We have to model how that water moves through the surface of the soil and on down into the subsoil layers. So again, we look at these layers both from the atmosphere down through the root zone when we're looking at agricultural meteorology. I'm not a big fan of slides with words. This is the last slide I think I have with a lot of words on it. After that, we have a lot of good pictures here. So again, as our role here at USDA, we study weather variables that are applicable to the situation. So you'll see in a minute here, I'll talk about winter wheat. We have to be aware of what the stage of the crop is, and from there we can look at critical temperatures, whether the crop has protective snow cover, for example. On the agricultural side, we look at applicable things like major and minor growing areas, what the stage of growth is, and we can layer all of that together and come up with fairly accurate assessments using a geographic information system to have these assessments for the U.S. and globally. Out of our office, our flagship publication is the Weekly Weather and Crop Bulletin. A lot of the assessments that we do are published in that weekly magazine. This magazine has a history going back more than 140 years, and in fact has not had a name change since 1924. So there is a long history. At one time this was a subscription service, but since the dawn of the internet, this has been a free publication available to anyone free of charge at the web address listed at the bottom. I'm just going to, I think the best thing to do to show what we do is to step through a few case studies, and I'm going to start off with winter wheat. One of the reasons I picked winter wheat is because it's one of the few row crops that's actually in the ground in the mid-latitudes this time of year. For those, and I do apologize for those that are highly familiar with winter wheat, I know we have some audience members that may not really understand how the crop works. It's planted in the fall in the mid-latitudes. It goes through a period of dormancy in the winter and then begins to grow again in the spring, finally heads out and is harvested in the late spring or early summer. And so this is a picture that was taken during the early part of the spring growth stage in Nebraska in April of 2013. Here's a graph that we like to use that shows some of the temperature sensitivity that wheat has at various growing stages. In the fall when it's planted and it has just a leaf or two, it can withstand temperatures that are in the teens to single digits without any concern. If it gets colder than that, we have to be concerned. During the full dormancy period in parts of December through early February, the crop can easily withstand temperatures down to near zero without any concerns. But we lose that winter hardiness very quickly in the spring. And by the time we get into the jointing and heading stages, flowering, it can take temperatures in the upper 20s to low 30s that can do harm. So it's very important to monitor the growth stages for winter wheat. Winter wheat's an interesting crop. It's been likened to a cat that has 9 lives. But truth be told, a lot of times winter wheat deteriorates over time. It's almost like nature's piñata. Nature takes whacks at it all through the winter and spring, whether it's drought or freezes or temperature swings, high winds causing soil erosion. So over time, over the last 20 years, we see about 4 years out of 5, winter wheat deteriorates during the winter. So one of our roles here at USDA is to monitor these extreme weather events as they apply to the health of the winter wheat crop. Just last winter in 2013-14, combination of bitter cold and drought took one of the biggest hits on history in the crop between autumn and spring. We also have spring issues as that temperature sensitivity decreases and we have spring freezes. If the crop gets too far ahead and we get spring freezes, that can cause great harm. So not only in 2014 did we have drought and damage in the wintertime, but we had problems in the spring as well. And so the crop really deteriorated in 2013-14. The year before that, in 2013, we had a series of spring freezes. We actually had a series of 4 to 5 freezes in some of the southern production areas. And so we monitored that all the way through. This happened again in 2014. But these freezes took quite a toll. We saw temperatures spiking in the 80s and then suddenly dropping into the teens. And so for 2 years in a row, we've had freeze damage on the winter wheat crop. About 20 years ago, when we didn't have much internet and we didn't have a whole lot of computing power, we devised a way to monitor the winter wheat crop for freeze injury potential during different periods of time. And so by the time we got into the early computing era and the early part of the 21st century, we were finally able to computerize this. At one time, we were bent over light tables trying to overlay snow cover data, minimum temperature data, and major crop areas. But by the time we moved into the 21st century, we were finally able to quantify this in a much prettier way. We weren't shading by hand anymore. And so this is just an example from the early era of computer monitoring when we were able to look at freeze injury potential with a couple of January outbreaks in 2004 that helped to pinpoint crop damage to a small area in northwestern Kansas. This was a winter wheat crop U.S.-wide that turned out pretty good, but we did see some localized damage in northwestern Kansas from cold outbreaks in early January and late January of 2004. And this was really one of the first times we were able to use this technology, layering data and crop information, weather data and crop information, to make an assessment that turned out to be true. This is a much more recent example. This happens to be the polar vortex, the time when the media leaped on the polar vortex terminology and made it a household name. This was January 6th, the first of the 3-day outbreak in early January 2014. And this, with the colors, you see the purples and the blues, that was snow cover, with the brighter colors being deeper snow cover. You can see the minimum temperatures in yellow, and off to the lower right, you can see the major and minor winter wheat areas. So we had a lot of concern during the early stages of this polar vortex period, Monday, January 6, 2014, that we had very little, if any, snow cover in southern South Dakota, parts of Nebraska, and north central Kansas, temperatures plunging in the -10 to -15 degree range. This was one of many hits on the winter wheat crop in this 2013-14 season, and severely degraded the quality of this crop as we headed towards spring. And sometimes we like to back up all this remotely sensed information with ground truth or satellite truth, and you can indeed see from the satellite picture that day that there was a significant gap in the snow cover stretching from southern South Dakota to northern Kansas. And this was, again, just one of many blows on this winter wheat crop in 2013 and 2014. I'm going to move over to corn, grain corn. This is a crop that's extremely versatile. It's not the sweet corn that we eat from the supermarket. This is grain corn that's used from everything from ethanol production for use in your gasoline to corn oil used for foods and everything in between. So speaking of corn, I'm going to look at a case from 2009, which some of you involved in the agricultural community might remember was at that time a record year for corn production and yield in the United States, but it was also an incredibly late developing crop, and because of the price of fuel and the price to dry the crop down, propane at that time, a lot of farmers opted to leave that crop in the field, at which time it began to rain and then eventually snow. Fortunately, grain corn is very hardy. It can sit out like that without too much harm to the crop other than the deer coming by and nibbling on it from time to time. But 2009, again, a very late developing crop. One thing we were watching here at USDA was seeing if we could get that crop through to maturity before we had our first freeze. It was very fortunate for the farmers that year, because if we had had an early freeze in September or even early October, it may have decimated that crop, especially in the western and northern Corn Belt. So we were monitoring day by day and week by week to see if we could get this crop through so it could stand out in the field like that previous picture from the cornfield in Nebraska. And it made it. By the time we got to October 5th, we had seen a season-ending freeze in only about 3% of the Corn Belt. And we made it a few more days past that, and that crop made it through. So we got the record production, the record yield. That could have been a different scenario if we'd had an early freeze that year. We also look at corn and drought as a parameter that has become very popular. Good news right now as we head into the growing season of 2015 is only about 8% of the U.S. corn production area is in drought. Most of that's the irrigated corn in the southwestern part of the belt down into Texas and western Kansas. We have had a bit of a snow drought in the upper Midwest this winter. If we have any observers up there, we've had more snow down this way than some of the folks up in the eastern Dakotas and Minnesota this winter. But by and large, we've got a pretty good soil moisture situation heading into the spring of 2015. That previous chart was based on the U.S. Drought Monitor depiction, which currently shows about 1/3 of the country in drought, but most of that's focused on the southern Great Plains and the far west, including California, where drought is moving into its 4th year. Now, it was a different story 2.5 years ago. Summer of 2012, that was the year we lost about 1/4 of our corn to drought and heat. And at the peak of the drought, the height of the drought in September 2012, not only did we have 2/3 of the country in drought, but we had 84% of the U.S. corn production area in drought. And it's a miracle that we only lost 1/4 of the crop when you look at some of the weather stats from that summer. There's the drought monitor map that went with that. That is a U.S. drought monitor record, almost 2/3 of the country in drought at that time in September 2012. And all during that growing season, from pollination on through harvest, we had more than 80% of the U.S. corn belt in drought. We don't just deal with row crops and things that stay still. We also deal with livestock, cattle. And obviously no drought in this picture from Nebraska. The year following the drought of 2012, we had a pretty wet, cool spring that year. These guys were wallowing in mud by that point. And at this point, Nebraska is in pretty good shape, as is much of the Corn Belt, but we still have more than 1/4 of the U.S. cattle inventory in drought. And again, that focuses on that drought across the southern Great Plains, as well as the California drought really dominating, with the cattle numbers pretty high in those areas. It was a different story for cattle 2.5 years ago as well. In fact, there was so little hay and grass at that point. The only good hay in the country, the only grass we had that was really growing at that point, was in the southeastern U.S. And so farmers were paying exorbitant sums to have that grass and hay trucked in from the southeast, as much as 2,000 miles to feed the cattle that year. More recently, we also deal with just about any weather extreme. I mean, kind of CoCoRaHS and agricultural meteorology go hand in hand. I think a lot of us observers out there really love the extremes. Maybe it's tough to get out there and take those measurements when you've got ice and snow in the gauge, but that's kind of what we live for in a lot of cases. Anytime we have extreme weather, it is a big deal for agricultural meteorology. Just last Friday, we had a freeze, the coldest weather of the season, down into Florida. You may have seen pictures of strawberries iced up, oranges iced up, as producers try to get protective ice caps on some of those fruits. Looks like we escaped without too much harm, although blueberries in North Florida and South Georgia may have taken a hit from this cold weather event. It was very unusual for this late in the season. And just to finish up with a couple of slides, pretty much any time we have a hurricane or a former hurricane hitting the U.S., we usually get called on. This, not so much of an agricultural impact. We were just asked to provide rainfall and wind information with former Hurricane Superstorm Sandy in late 2012, which really impacted, obviously, the Northeast and had epic snowfall in the Appalachians from that system. And the year before that, Hurricane Irene was a big deal for the cotton areas of North Carolina and Virginia. As the cotton bolls were opening, they were battered by winds that were anywhere from 40 to 70 miles per hour. So anytime we get extreme weather like that, we in this office are called on to provide assessments for agriculture. So just in conclusion for my part, and then Mark will step in, anything from drought to flood, and everything in between, that's our job. We get busiest when the weather is extreme, just like we've seen this February in the U.S. And if you want to see the faces behind the names, we are a group of 5 of us. We've lost 2 to retirement. And in typical government fashion, we haven't hired behind that. So we are a short-staffed group of 5 agricultural meteorologists within USDA. And I'm on the left, Mark is on the left, and at that point, I will turn it over here to Mark, and he can take over. Okay. We're trading places, so bear with us for just a moment.
Thanks, Brad, and thank you all for inviting us today. I think this is a really good experience. One of the first things that I'd like to do, first of all, this is me. I'm not as dour looking as my picture. That was, I have to apologize for that. That was my passport picture, so please don't think that I was in a really bad mood when I was asked to do this. I really enjoyed doing things like this. First of all, what I'd like to talk about is some of the reasons that we do what we do here in Washington, D.C. I get a lot of questions. Why does the USDA have meteorologists, and why are they concerned about weather in other parts of the world, not just the United States? And what I have here is a copy of a report. This is the World Agricultural Supply and Demand Estimates Report. Our agency puts this out every month with the help of some other agencies, including the Foreign Ag Service and the National Ag Statistics Service. And what I have highlighted is a little section from the cover of the report from September of 2012, and it describes a drought in Russia and actually parts of the EU, former Soviet Union. We were instrumental in detecting that drought, and that allowed us to adjust our estimates for both Russia and Kazakhstan and other parts of the world. We're called upon to do this every month, and the quick story is, in the past, I won't go into too much detail, in the past we've been surprised by other countries having drought or other forms of bad weather that's impacted the global market. So the reason that our agency exists is so that we don't get caught off guard anymore. And we know what the weather's like in other parts of the world. This is what the structure looks like. We report to the chairperson of the World Agricultural Outlook Board. He reports directly to the Chief Economist, who in turn reports directly to the Secretary of Agriculture. Here's where we are. We are, as Brad mentioned, a block of 5 meteorologists now. Brad is the U.S. Analyst, and the other 4 of us are almost exclusively called upon to monitor international crop weather. We do back each other up on occasion, but it's basically 4 of us covering the world outside the United States. One of our main responsibilities, as Brad mentioned, the weekly weather and crop bulletin, and I just showed you the WASDE report, but one of the things that we're tasked to do is to collect global ag weather information, not only for support of the WASDE report and the weather and crop bulletin, but we're also the focal point in the USDA for international and domestic weather for other agencies. What we do is we collect this data, which we receive from the Climate Prediction Center. This is basically the flow of information going into the Joint Ag Weather Facility. By agreement with the Department of Commerce, we have formed an entity that we refer to as the Joint Ag Weather Facility. That basically means we're partners with agencies within the National Weather Service, and we also partner with the National Ag Statistics Service to get domestic crop production statistics, which we publish in the Weekly Weather and Crop Bulletin. Now, why is it important that we monitor international, agricultural areas? And this is basically the short answer. This is a production map showing the 3-year average in the United States, Brazil, Argentina. These are the top 5 soybean producers in the world. As you can see, we're a leader, but more importantly, if you look at exports, we're no longer the leading export in the world for soybeans. It's now Brazil. It's been Brazil, Argentina, and Paraguay combined for several years now. So as you can see, we have competition, very strong competition in the Southern Hemisphere and in other countries. You see Canada is also a big exporter. So that's it in a nutshell. It's global economics. We need to know who our competitors are going to be and who our potential customers are going to be, and that's why we monitor the weather. And this chart from several years ago shows what happened to soybean prices based on a drought that they were having in Argentina. Now, as you can see, the April prices shot up, and if you think about it, in South America, they're harvesting about the time that farmers in the United States are making preparations for their planting. So these prices, because of the drought in Argentina, affected planting intentions in the United States, And once our crops are harvested come October, November, the folks in South America are going to be making their decisions. So it's all interchangeable. We're watching what they're doing, and they're watching what we're doing, and that's it in a nutshell. Now, some of the press reports that we get, and I'm sure you hear on the news, really highlight the impact that weather has on the global economy. And this is just from this past month. We see commodities being affected by weather in Brazil and Argentina, but also China. Hailstorm in India made the news. We talked about the sugarcane in Australia recently. And you see even in northern Africa, they're having issues with crops. Actually, they're expecting a favorable harvest. Not on here is a winter kill issue that we're watching in the former Soviet Union as well. So people are watching this globally, and a lot of times we're asked to comment on some of the things that are happening. For example, is the rain in Brazil, is that really helping, or are things too far gone? So a lot of times we're asked to make assessments not just on what we're seeing, but what other people are saying as well. So we have to have a lot of information coming in and out of our shop here, not just weather information and products. Now, the weather data, I wanted to touch upon this, and I thought this was a good opportunity to talk to people who are actually collecting data. This is what the stream of data looks like. We are under an agreement with the World Meteorological Organization, WMO, to receive and also transmit a subset of the United States weather observations. So the United States as a participant provides a subset of our data to the world, and we get back a subset of the data from participating countries. Now, on any given day, you see that we get anywhere between 6,000 and 8,000 stations. A lot of these data have a really good history. Some of them have normals with them. Now, this looks like a lot of coverage, but as you can see, and as you know from your own experiences, a lot of times what's happening in the United States, you have to look at all of the individual networks. Now, here's an example that I've selected for Mexico, and on the left, you see those WMO stations in Mexico, and there are 70 of them. Well, that sounds like a lot for a country the size of Mexico, but consider that sometimes there's data transmission errors. We don't always get all of the data. Now, there is on the right that I'm showing a rain gauge network that we don't directly get through the WMO, but we get through other agreements. And here's the difference. This is an analysis from a week ending in early April in 2010, and this is around the time that you would expect the Mexico rainy season to start in some of the major corn areas in the south central part of the country. Now, had we only had WMO data on the left, we would have assumed that the rainy season was off to a good start. But if you look at the right, once you start bringing the Mexico rain gauge data in, we see that the rainy season is beginning in parts of the east, especially up in some of the northeastern areas, but the central and western part of that Corn Belt area, we're not getting rain. So we needed this additional information, and this is sort of, it not only is CoCoRaHS important in the United States, but you see how some of these other networks are important globally. And as Brad mentioned, we do have other forms of information. This is a product called CMORPH on the left. It's basically a morph of all of the CPC satellite estimates, and you can see that the satellite estimated rainfall also did a pretty good job showing exactly where the rain was. So we can't just look at what we would refer to as the first order data. We have to use a lot of tools. Now, one of the things that I do as South America analyst is I'll try to collect crop production data from the countries. Now, this is Argentina, and what we have on the left is a map showing the intensity of the corn yields, and on the right we have soybean yields. Now, those red dots are WMO stations in the main crop areas. Now, the WMO stations work well in this instance because there is a history. I can go back and look at other years. So what I've done is I've created a region in an area that represents some of the highest corn and soybean yields for Argentina. Now, looking at this year, 2014-15 year is in red. What I can do, once I have that region established, I can go back and look at similar years. Now, in this case, they've had a pretty good year because they've had rain for just about all year, going back to September when they were just planting corn. And you can see that the last two wet years were in 2006-07 and then the 09-10 year. And we have other years of data, but these were the ones that were closest to what was going on this year. Now, I can go back and look and see what the yields were, and what this is showing is corn. I've circled the 2006-2009 year, and sure enough, those wet years were record yields for corn in Argentina and also for soybeans. What I can do also, and I have to thank a colleague of mine for running this model for me, we can do a regression model based on weather parameters to actually try to get a yield number, not just say, hey, it looks like it's going to be above normal. In this case, we have a very good yield of 8.53 for corn. And again, this is just a model, but what we're showing is not so much that we absolutely believe the yield's going to be 8.3 or 8.53 tons per hectare, but we are reinforcing the support that there is going to be upward pressure on yields based on the weather. Some people thought that it might have been a little too wet this year, and we were able to show, no, it's really hard to be too wet for corn in Argentina. You know, it looks like they're having a good crop. Now, another thing that we take into consideration is the climate and what they're actually trying to do in the country. Now, this is a soybean map of Brazil, but what I've done is I've marked with this blue line the climate division. South of the blue line, they tend to have a subtropical climate. North of the blue line, they have a tropical wet and dry season. And what this means is, if you look at this daily rainfall map, these blue areas here show daily average rainfall in that tropical zone. And you see that they have a very distinct dry season, say from the middle part of May to the early to middle part of September, and then it starts raining like gangbusters. Farther south, the red bars are showing that they get rain pretty much all year round. Now, the reason that this is important is they tend to grow more crops farther north where it's warmer, but they have to be very careful about the timing of the planting because the rainfall will shut off. Farther south, they have more consistent rains all year round, but they do have freezes. So the farmers really have to balance a lot of decision making depending on exactly where their farms are. Now, case in point, what I've done is I've listed Mato Grosso, which is the country's leading producer of both soybeans and corn by state. This is what happened last year in 2014. And what I've done is I've looked at the three scenarios. Now, if you look at the red line, and here's the black line, and sorry for jumping around too much, but this black line is the average. And you see where it flattens out, that's telling us that that's when the rainy season ends. Now, we're looking at these years, and we had some analysts who were saying, well, it was above normal, and that means that we're going to have above normal yields. And we had to say, well, not so fast, because if you're looking at corn that's planted after the first soybean crop, they need rain to last into the month of May. So just stepping through these years, the year in 2011 where it looked very similar to last year, but they went bone dry, you see from the chart in the lower right-hand corner, they actually had below normal yields for their second corn crop. So looks were very deceiving. In some of these other years where it looked like it was drier, if you take a closer look, they actually had rain later in the year. They had some March and April rain, which was very timely for the corn crop. So they didn't have as much leading up to it, but it was positioned well during their entire growing season. And the same happened in 2013. So, you know, the bottom line is we couldn't just look at the absolute amount of rainfall that they had for the season. We had to very carefully look at them week by week, and we had to watch when they planted the soybeans and when they harvested, and then when they planted the corn and when they harvested that. So we have to watch this on a weekly basis, and we have to have good crop intelligence from the countries. We actually have people that travel to Brazil and Argentina and the other countries who are involved in this WSDA process. So we do get firsthand glimpses of what's going on in the countries. Now, another thing that we have to do sometimes is when we don't have good weather data or good information, sometimes we have to look at things regionally. And what I have here is the soybean map for Brazil. And remember, this is a similar climate zone down here in Paraná and Rio Grande do Sul. Mato Grosso do Sul is a country, or excuse me, a state where we just don't have as much good weather information. But if you look at the yield trends, we can model pretty well Rio Grande do Sul and Paraná. We get a very good fit. So if we get a good fit in some of those countries, or in some of those states rather, what we'll do is we'll try to see if that can translate to other states. So what this is showing is basically when the yield is up in Paraná, it's usually up in Mato Grosso do Sul, and vice versa. When it's down, it's usually down there. So taking the states that we do have a lot of information in, this helps us to know whether or not we're going in the right direction. So we try to squeeze as much as we can out of the information that we have. Sometimes it works, sometimes it doesn't. But last year we did, I think, a pretty good job in determining what was going on in Brazil. More recently, we had a situation in Brazil where some of the really important growing areas, say about 70 to 80% of the crops here in central Brazil, all the way down into the south, we're getting very high amounts of rainfall. But this area here dried out. They had a high pressure dominating that was positioned off the Atlantic, and it was keeping rain out of some of those areas. I was asked how much of the crop was affected, so I went back. I downloaded some statistics from the Statistical Bureau of Brazil, and by masking out where the crop was grown, I estimated that about 25% of the corn acreage, or excuse me, about 25% of the soybean area was impacted, and about 34% of the first corn crop was impacted. None of the second crop had been planted yet. So this helped us fine-tune exactly what part of the crop we were looking at. So just like Brad showed in the United States, if we have a drought or if we have flooding, we want to see what we're really talking about in terms of what percentage of the crop is affected. We're also able to do that. In fact, we're forced to do that in Brazil and Argentina, especially since they're such big competitors of ours. The first crop, corn, that was affected, if you go back to the year ending 2009, you see that the states affected produce about 20% of the crop. However, there has been a shift, and if you just look a few years later, we see that it was closer to 30%. So, you know, we can't just look at one map and let it go for 10, 15 years. We have to continuously see what the farmers are doing in these other countries, because there is a big shift in agriculture, especially in Brazil. So we have to really stay on top of what they're doing, what the economics are, and what the decisions are from year to year, so we know exactly how much of the crop is being impacted by some of these weather phenomena. Now, the other thing that I want to talk about is we also have to monitor things like the El Nino. This is an example of a press report we had back last autumn, and there was already speculation that if there was an El Nino, it would cause damage to certain crop, several types of crops in different parts of the world. So we had to monitor this. We knew that there was a forecast for an El Nino, but we had to address a lot of the concern. Yes, Australia is impacted, as are some other countries, but we had to take a really close look. So what I did was I broke down what the impact was going to be, and this is a chart that I borrowed/stole from the National Weather Service El Nino site, and it is showing that you would expect dry weather impacting crops in Australia. Now, if you take a look at the Australia wheat year, what I've done is I've marked the El Nino years, and you can see that most of the years are affected negatively by an El Nino. So it wasn't really unusual to say, hey, Australia, there's going to be an El Nino, Australia's affected, so we can expect there to be a bad crop. Well, again, like I said earlier, it's not so fast. You have to take a really close look at this. So what I did was I looked at several El Nino episodes. In fact, at 4 of the last 5 that were pretty distinct. And you see this 1997 year was the strongest El Nino in terms of sea surface temperature anomalies that we really have in recent memory. And some of the other ones are I would say, moderate to weak El Ninos. Now, if you look at what happened those years, you see that the year where they had the strongest El Nino in Australia, they actually had above-trend years. And it was actually the weaker events where there were worse droughts. So, yes, there was an El Nino, but again, this year, this 1997-98, this really gives you pause before, so that you don't jump the gun and say, well, okay, there's an El Nino, so that's guaranteed that these things are going to happen. And sure enough, if you look at the actual weather data, this might be a little hard to see, but this light blue line is the 1997 year. And they did indeed have periods of extended dryness, but they had shots of rain as well. So here's a couple of weeks of dry weather, but then they had just a boatload of rain exactly when they needed it. So it wasn't a great year in terms of the weather patterns that went through, but when they did get a low pressure system and a front through, they got a lot of rain. And they had 3 to 4 inches of rain in the month of September, right when the wheat was reproductive. And again, that was a fun year because I was the analyst for Australia that year. And one fellow in particular, I fought him tooth and nail. He was saying it's an El Nino, it's going to be below normal. And I kept saying, just wait for the rain. Is it going to rain? Now these other 3 years here, that was easy. It just never rained. But this was like riding a roller coaster. And just when it dried out, and you thought that the El Nino was going to take over, they would get ample rain. So it was a very fun thing to watch. And that's really all I have. I went pretty fast, and I touched on a lot of things, but I hope that everybody has at least some understanding of why we monitor international weather and what the implications are for weather in our own country. We see the price impacts, and we see that it helps the farmers make decisions. If they know that there's going to be a corn shortage in Latin America, that might change their minds in terms of whether or not to grow corn or soybeans in their own farm. So, again, that was quick, and I thank you. And I guess I'll turn it back over to CoCoRaHS and see if there are any questions.
Thanks, Mark and Brad. Really very informative stuff that probably a lot of people didn't know about, and appreciate you guys taking some time to do this today. We're going to take questions from our audience right now. If you have a question for either Brad or Mark, or for both of them, go ahead and type it in and include your state and your name, your first name. That'd be great. I've got one that came in earlier today. Marty in Maryland wanted to know, as a general rule, shouldn't we expect to see higher harvest yields from all crops, given that global warming has increased the length of the growing season in many parts of the U.S.? What do you guys think of that?
Sometimes it's tough to sort out all of the plant genetics going on with some of the climate issues as well. So I think it's tough to sort that out. I mean, we see trends for just about all crops heading up but we know that there's been a lot of seed genetic work as well. So I don't know how much we want to take that one on, just knowing that we have upward trends for various reasons.
Yeah, and I'd, just real quickly to just build on what Brad said. In Brazil, I mentioned that they grow a soybean crop and then a second corn crop. Well, to take advantage of growing the second corn crop, they've actually developed lower yielding, shorter variety soybean crops. So we're seeing cases internationally where farmers are willing to take a hit to try to squeeze in an extra crop. Now, if the temperatures and maybe an extended rainy season help that, you know, you could see husbandry turn in that direction, where they can say, hey, we might have a longer growing season, let's try to get the most out of it.
And I guess I would just add to Marty that we obviously do see some trends in agriculture, so we're pushing soybeans up into areas that have never had them before. Until recently, North Dakota accounted for 7% of the planted acreage or harvested acreage for soybeans in 2014, and that's far and above. I mean, historically, the last couple of decades, it's been 3 or 4%. So as we push some of these crops into these marginal areas, we might see, I guess, some slight reductions in yield overall. But I mean, again, the plant genetics are pushing it in the other direction towards up and up and up, it seems like, for corn and beans and a lot of the other major crops.
Okay, thanks, guys. Here's one from Chapel Hill from Jordan at the Southeast Regional Climate Center. He wants to know which crop grown in the United States is the most difficult to predict yields for due to weather variability.
I would have to say that it is crops that have high abandonment rates, such as cotton or winter wheat, because you're actually, I think, better off looking at abandonment rates rather than yield numbers, because it can give a very misleading picture. I tend to stay away from looking at like winter wheat yield for the very reason that you take out all that abandoned acreage and your yield looks inflated very high.
Okay, thanks. Here's Kevin in Delaware wants to know, that a question for you, both you guys, is how did you get into the ag weather forecasting business? What path brought you to where you are today?
Yeah, I think for all 5 of us, it was a little bit accidental. Myself, I was trained as a forecaster at Penn State, and I really didn't have that much of an agricultural background. I mean, you have to go back 2 generations to my grandparents to find agriculture in my family. So a bit of an accident, but it's really rewarding and enjoyable. Just a very small field.
Right. I took a different path. I grew up wanting to be a TV weatherman, so I majored in radio, television, and film. And then when I started taking the meteorology classes, I liked the science better than the broadcast. Plus, as you can tell, I have a face for radio, so I don't think I would have lasted on a TV station very long. And getting in USDA, I happened upon a summer intern job at the facility where we're working now, but I worked on the National Weather Service side. And I really liked what I did, and as I went farther in school, I started taking more agricultural courses, and I pretty much shaped my own career path.
And I will add out there that we have had a lot of on-the-job training to make up for our lack of experience as youth, a lot of crop tours and farm trips and so forth to help get some of that under our belt and actually understand what's going on.
Do you guys have your own gardens at home? Do you grow anything?
Yeah, on a very small scale, certainly not a farm scale.
Okay. Here's one. Alan in North Alabama said he had 6 to 10 inches of snow today, which is kind of unusual for those guys. And this is just a general meteorology question. Do you think that will affect their water table? And he was just wondering how that would affect the crops.
Usually snowfall like that is really good for the water table and hydrology in general. Rainfall, especially if it comes too quick and too fast, it can run off. Snow is one of the best ways to get that moisture to percolate into the soil, and especially having a late winter event like this, that's great for spring planting preparations to moisten up the topsoil.
Okay, here's one from Dave in New Mexico, and Dave wants to know, are you seeing increased difficulties in crop predictions, or increasing difficulties in crop predictions worldwide due to weather variations over the years, or has it just about been the same?
I think it's been a little easier for us to find out where the trouble spots are with the advent of some of the satellite products, because just case in point, we've had drought off and on in parts of Europe and the former Soviet Union, and that showed up really well on some of the satellite imagery. And we actually had an incident last year where some of the WMO data that I talked about earlier went bad, and we didn't get that data, and we were able to monitor rainfall using satellite estimates. So just having more material and to be able to go on the internet and download updated crop statistics like I showed, I think we're benefiting from the technology.
Yeah, Steve writes, and it's just the same what you just answered. You want to know about the satellite data to supplement the estimates. Is that worldwide? Can you use that worldwide, the coverage on that?
Yes, we do use it worldwide. Some of the satellite products don't work as well in different parts of the world, like the satellite rainfall estimate product that I alluded to doesn't work that well in the higher latitudes. It's more of a tropical product. So I can use it in some of my areas. In other areas, it doesn't help me as much. Yeah.
Okay, here's a question from Julie right down the street there in Maryland, and she wants to know what's your typical work schedule like? What do you guys, what does it consist of?
We are a normal Monday to Friday operation, but with the extremes, we can get really, really busy at times. Once in a while, we'll have to run over, work late. But we're not a 24/7 operation, so we do try to adhere to a Monday to Friday schedule. But the weather happens all the time, so sometimes we get drawn a little bit thin on the hours.
Right, and since all of us are kind of weather geeks, we're always at night. We're on the National Weather Service site, and I go to some of my international sites and I look at the weather. So we're, you know, I guess it's in our blood at this point. So we are looking at the weather, but we just don't get paid for it 24/7.
Thanks. Here's Bill in New Jersey, and he wants to know, do you use CoCoRaHS data at all? So are the observations our observers are taking, are those important to you guys?
Yes, absolutely. And I've been a CoCoRaHS observer since 2008. My dad's been in longer than I have, and so we got a two-generation thing going there. But that data does go into the river forecast centers and ultimately ends up into the data stream. So we consider that a very valuable source of information. And the more we can get in some of the sparsely populated areas, the better. Obviously, you see the clustering around some of the cities, and that's great too. We need it all, but we love to see the rural CoCoRaHS data.
Right. Back in December, when I think for like only a 2 to 3 week period they had rainfall in California, I actually sent a CoCoRaHS map across the street. Well, across the street is our administration building, and it made its way to the Secretary of Agriculture's office. So that we do use that, and people take it seriously.
Thanks. Yeah, keep up your measurements out there, folks. You don't realize how many folks are using, or entities are using, the CoCoRaHS measurements around the country. In fact, if you go to our website on the left-hand side, you'll see there's a whole series there that we show of who's using them. Here's Chuck from Indiana, and Chuck said cold, sunny, windy weather there, and he said the sublimation has removed a lot of the snow. Is when you guys are doing this stuff, is moisture loss like this taken into consideration?
I did talk a little bit about soil moisture measurements and modeling. So that's because we have a shortage or very few soil moisture measurements, we may not be fully taking into account. That's a little bit more rare in Indiana. It's much more common in the west, some of the higher elevations where Chinook winds can just eat the snow, literally. So that is a problem. Mark actually here is working on a a project to try to get more soil moisture sensors out there, to try to get, instead of just a few hundred, maybe one per county, so in the order of 3,000 or so. So that's an ongoing project, trying to get more soil moisture sensors out into our agricultural areas.
Yeah, Michael writes a similar question. Is there a simple, low-cost soil temperature measurement system that you could recommend? We're thinking of adding this to CoCoRaHS eventually, but is there something in the meantime that you guys know of?
I'm not aware of anything. Henry, you might be able to answer that better than we could.
Yeah, I mean, I could provide documentation on what the SCAN network and NOAA's Climate Reference Network uses, but I don't know. I mean, I don't know the relative cost. I'm sure that they're very expensive, and to install them properly is very problematic, because we take a soil profile and, to determine the soil types, the texture, everything. So it's not something that you can do cheaply. It can be very labor intensive as well.
And a similar question John had written is, so he wanted to know if there were initiatives in place to increase the number of U.S. soil moisture sampling stations, and I believe there are, and you guys are working on that as well. So.
Yes, yeah, and it's a long process, because there are a lot of soil moisture networks being run both by the federal government and the state and universities, and quite frankly, all the networks are different. I mean, the sensor depths vary from site, well, not site to site, but from network to network, and some networks record percentage of soil moisture, some try to do a calculation on the actual amount of moisture available, so they're reporting different things. So they're not only are they reporting at different levels, they're actually reporting different numbers, and it has been a challenge to try to get everybody on the same table, or on the same page rather.
Terry notes that we do ET measurements, the ET gauger with CoCoRaHS. We probably get over 100 reports a year on that. Are you guys picking up any of that stuff and using it at all?
It also ends up into the data stream. I would like to get, the one thing we publish in the Weekly Weather and Crop Bulletin that's not, I don't think shows up anywhere else, is pan evaporation, which we use for, agricultural purposes. But as far as I'm aware, I mean, we don't use that in this office here, but I'd have to talk to some of the folks in the Weather Service that may be making it into some things I'm not aware of. I'll have to get back on that.
Great. Paul in North Carolina writes, and he was wondering if you guys could address what might be causing the drought in California, and how will that affect the breadbasket of the country. I assume by breadbasket he means the crops grown in California.
Right. Yeah, there seems to be a couple of things that may have triggered the start of the drought in California. La Nina back several years ago may have had a sort of a trigger factor there. But more recently, a really troubling thing has been the warm water across the eastern and northern Pacific Ocean. It seems to be anchoring a ridge, and that has been a problem now for more than 18 months. So we seem to keep getting a western ridge, eastern trough, hence the cold winters in the Midwest and Northeast, and the warm, dry conditions across west of the Rockies. We need to, that may be related to some longer decadal type features like the Pacific Decadal Oscillation, but that's just speculative at this point. In terms of being a fourth year of drought coming up in California, they're probably going to face water restrictions as great, if not greater, than they did in 2014. We had big cutbacks on more than 10% of the fields were left fallow in 2014. I would expect to see that again. And also, I mean, a lot of the water that is available is going to keeping some of the perennial crops like trees and nuts and vines alive, and that will have to continue, I think, in 2015.
Here's a gentleman writes in, Gavin here, actually from Fort Collins. Question for Brad. He says, do you produce a product for times when there is specifically no snow cover and very cold temperatures? He says, what I'm referring to is the winter wheat example and the gap of snow coverage in Nebraska, Kansas, and am thinking about the effects of cold soil temperatures on perennial biofuel grass crops.
I suspect that we may have to produce something for what's going on right now up there, if that's what he's referring to. We've got the cold this morning and again tomorrow morning that may cause concern. We may have some special products coming out about that. We don't have anything routine. We usually, on a case-by-case basis, if we see something that warrants a special report, we usually do go and publish that. That'll go across the street to administration and often appears in the weekly weather and crop bulletin.
Okay, here's Tyler, and Tyler wants to know, do you think the space race for weather and climate forecasting privatization will affect information sought after and collected, used by and evaluated by the USDA and other government entities? So he's asking, do you think this information will prove more or less valuable than what we collect now?
Yeah, that's, I guess, a problem both domestically and internationally. Some of the foreign countries have proprietary information that they will only sell meteorological data. Mark might be able to address that better. Domestically, we've kind of gone back and forth on this public-private issue for a long, long time. There have been a lot of battles fought between the privates and the federal government on just what the role of each should be. Right now, maybe we're at a little bit better place than we were back in the 90s when that battle actually got pretty animated for a while. But I expect that battle will wax and wane over time, and hopefully we can strike a balance where we can get that information out to the taxpayers like what we're doing, but so that some of the folks who want to make money off that can do it as well. Hopefully we can strike a balance on that. It's very tough, though.
You know, what I'm starting to see, and we discussed this at some meetings, there are private companies out there developing weather apps that will allow farmers to do precision agriculture. So they can actually take some of those products, go into their fields, get the the exact position, and they can more efficiently irrigate, more efficiently apply fertilizer. That might be where the private sector is going to make a lot of gains, in the coming years.
Okay, so we have one last question here. Tommy, well, here's another one. There's a little more coming up. Tommy from Virginia wants to know, does snow help insulate winter crops in extreme cold? I think you've answered that, but maybe you could talk about it again.
Yes, most definitely. Snow is a wonderful insulator, as I guess the Eskimos figured out a long, long time ago. And so it doesn't take a whole lot. Sometimes as little as an inch of solid snow cover can provide much needed protection to the roots and the lower reaches of plants. Thinking of winter wheat, but also ornamental shrubs can be protected by snow cover as well.
Henry, you muted yourself.
Well, thank you. Sorry, I pushed the wrong button. Terry from, we're going to wind up with this one. Terry wants to know, is there a network of soil moisture gauges across the country that you can view? So is there something online that they can take a look at with these?
Okay, there's several things that you can look at. Individually, you can go to, and I don't have the websites, I can provide these with you, but if you can Google these, USDA soil moisture networks are maintained by our Natural Resources Conservation Service, Water and Climate, National Water and Climate Center in Portland, Oregon. It's called the SCAN network. So if you Google SCAN, S-C-A-N, and USDA, you'll find the site there that you can look at it. The National Weather Service is implementing soil moisture at their climate reference network. So I'm sure if you Google NOAA and then CRN network, you'll get that. And then finally, this movement or coordinating effort that I'm talking about, or I talked about earlier, there's a fellow, I believe his name is Steve Quiring, Q-U-I-R-I-N-G, at Texas A&M University. He has a site where he lists all of the networks. Now, you can't go there right now and get, say, a map of the United States with all of the data plotted, but it'll show you where those networks are and who's participating in these pilot programs that they're trying to institute. So that's Texas A&M University is a good place to go, and then individually the USDA Scan Network and the NOAA CRN Network.
Yeah, actually, Steve is one of our CoCoRaHS regional coordinators down here in Texas. So I'll ping him and get that information. Kevin Brinson from Delaware, the climate center there, is also in the National Soil Moisture Database. So we'll put that up. And what we'll do is we'll get these online for you guys. We'll post them later this week under resources. And if you go to the page, the CoCoRaHS Weather Talk page, and click on this webinar, you'll see all that. Well, gentlemen, thank you so much for taking time out of your day today. It's great to have you with us. Really some good stuff, and I'm sure our audience has gained a lot of knowledge in this area. So thanks, and we'll hope we'll see you again sometime soon.
Thanks. Our pleasure. Yeah, thank you.
Well, CoCoRaHS Weather Talk is going on vacation. I think for those of you who weren't at the beginning, we're going to take a vacation after 39 continuous episodes. So that's quite a while. We've been going for almost a little over 3 years. We'll be back later on this summer with a lineup of exciting webinars, and we're working on those right now. So check back, I would say, mid to late summer on our website to see what we have in store. We'll also send messages out. And finally today, when signing off, would you please take the survey? It'll pop up on your screen, and we appreciate you doing that. So until later this summer, this is Henry Regis for the rest of the CoCoRaHS team saying goodbye for now, and have a great afternoon.